In this video we are going to graph the secant function. Some information about it really quickly. A lot of it's the same as all the other trig functions, specifically sine and cosine. The amplitude, we're not going to really call it an amplitude this time, but it still has the same effect. So the amplitude is, with sine and cosine, is like how stretched out from the midline the graph is. That doesn't make sense if we don't have a sine or cosine wave. So we're still going to think of it as maybe an amplitude, but what it does is it simply just makes these alternating U-shaped graphs further away from the midline, which in this case would be the x-axis here. We can still have a phase shift. We still find the period using 2 pi divided by k. Still have a vertical shift. The domain's a little tricky here. The domain is all real numbers except x cannot equal pi over 2 plus k pi. So what this k pi is, it's any integer multiple of pi. So the idea is this would be pi over 2. So there's going to be an asymptote here at pi over 2. And then if I add any multiple of pi to pi over 2, so if I add 1 pi to it or 5 pi to it or anything like that, I'm going to get another location of an asymptote. So if this was pi over 2 right here, then this next asymptote, which would be right here, would be the first addition of pi to pi over 2 to get me that next location of an asymptote. And that would just continue on in that fashion forever. So I'll show you through Desmos really quickly. Again, if I were to graph x equals pi over 2, there's one of my asymptotes, and then if I just add a multiple of pi to that, I'm going to get the next asymptote, and then the next asymptote, and so forth, and it's just going to continue on forever in both directions doing that. Okay, and then the range is all real numbers. So we're going to go ahead and graph y equals secant x, and to do so, I'm going to go through kind of this information again, just like we did with our other graphs. And then when we get all that information, I'm going to show you how to easily make your XY table to understand what's happening for your graph. So the amplitude, quote-unquote amplitude of this, there's no number in front of the secant there, so it's an understood 1. The period is 2 pi divided by k, which means our period is 2 pi. There's no phase shift, and there's also no vertical shift. So just like with sine and cosine that we did before, if the period's 2 pi and there's no phase shift, we're going to start at 0 and we're going to end at 2 pi, which means our other x values that we're going to use are pi, pi over 2, and 3 pi over 2. And then to get the y values, this is actually what I'm going to do. So let me go ahead and write those x values across here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. What I'm going to do is I'm going to understand that secant is the reciprocal of cosine. Okay, so if I think about that, what I'm actually going to do is I'm going to plot the points as if this were cosine. So let me, if it were cosine, let's see, this would be, I'm actually going to stretch this out a little bit. So let's make that 1 and let's make this negative 1. Okay, if this were a cosine curve, it would start at the top, so I'm going to put a point here. And then it would go to 0, and then it would go to the bottom, and then it would go back to 0, and then back to the top, right? If it were cosine. So because secant is the reciprocal of cosine, what those points are going to tell me is that where cosine is 0, if you think about cosine being 0, that means secant is going to be undefined because I'm going to get 1 over 0. So every place that cosine hits the x-axis, we are going to have a vertical asymptote for secant. So again, we've got one there at pi over 2, and then if we add pi to that at 3 pi over 2, those are both vertical asymptotes. Okay, and then all we have to know from that point is that every place where cosine is at +1, secant would also be at +1, and if cosine is at -1, secant would also be at -1. So these other points are gonna tell us the locations of the midpoint of these alternating U-shaped graphs. So I'm gonna have one here. I'm gonna have one down here, and I'm gonna have one up here. And again, they would just continue on in both directions as we continue to make that. So that's more than one cycle. One cycle of secant would be one going down and one going up. But if we just do the cosine in that fashion, we can kind of get more than one cycle of secant by looking at that. Okay, so I haven't even filled out the y-coordinates for this table, but I can now. Where cosine was 1, secant was also 1. It was undefined when cosine was 0. It was at -1 when cosine was at -1. Again, undefined, and again 1. Okay, so if we jump into another example here, this time we have a k value, so that's going to change our values just a little bit. Amplitude's still 1. Period is 2 pi divided by k, so 2 pi divided by 1/2 would give us 4 pi. Again, no phase shift and no vertical shift. So if our period is 4 pi, that means we're going to go from 0 to 4 pi, which means we would get pi, 2 pi, and 3 pi in the middle. And then, again, there's no amplitude change here, so it's going to be essentially the same thing that we just did, except our x-coordinate values are going to be a little bit different here. So 0, pi, 2 pi, 3 pi, and 4 pi. And then again, I'll do 1 and -1. And I will always, every single time, pretend like that's cosine and make those points. So there's one there, there, and there. And then again, where we have those, where cosine hits the x-axis, that is going to be where our secant function has asymptotes, and then we have these alternating u's where those other points are. So that's a quick way to graph the secant function, is to just think about cosine and do it in the same manner, and then know what that tells you about your graph when you do that.